A warm welcome, everybody, to the virtual Houston Azure User Group February edition 2022. A very, very warm welcome. Thank you for coming out to virtually see us tonight. And if you're on the recording, greetings. You missed it. It was awesome. You're going to miss all the chit chat. You missed all the chit chat at the beginning, and you're going to miss all the chit chat at the end. This is just the recording because we edit it, but that's fine. At least you watch the recording, so that's good. All right, my name is Adam Hams, and I'm the leader of this group. I run it and have done so since 2015 now. And we have some long-time members on the call with us and some newbies. So a welcome to you both. For the newbies, what this group is about. It is very much not the Adam Hems show. Although you missed in the chit chat earlier. Sometimes really wish it was the Adam Hems show, but that's not it's not fair to everyone else. So we don't do that. This is about a community. And this is about learning from others. And honestly, some of the very best presentations have been from community members of the community. There's been some really good ones. So there's honestly been some of the best. That's one of the reasons I resist the temptation to present myself, because frankly, other people's presentations, they're better. It's better to hear and learn from others. And also I tend to prefer my day job is I'm a cloud architect with Microsoft, and so this is my hobby. This is what I do for fun. More fun, honestly, when we're in person. I was griping about that earlier. Come back to a frequently asked question: when we're going to be in person again in a little bit. But nonetheless, this is my idea of fun, meeting and chatting and discussing people, and also learning. That's why another reason I like other people to present, because I get to learn from everybody. In fact, we have some previous presenters on the call here tonight, so a warm welcome to you. And so things that this meetup is intended to be: a place to learn from one another, and to explore and to chat, to meet others like-minded. If you are not familiar with Azure and this whole cloud thing, that happens a lot. We get folks who are just here to try and understand sort of what's all the fuss about, get some sense of what's going on. You're in the right place. If you're experienced with Azure, you've had a little time with it, quite familiar with it, again, you're in the right place. Or if you remember one of the other meetups, the AWS one, a lot of folks, including myself, who's a member of the AWS meetup. I try not to conflict with it, although I think I'm actually conflicting with it tonight, so that was my bad. Try not to do that so that folks can attend both if you wish. That's fine. Kind of interesting to see a bit of both, and many companies have a bit of both, of course. But this meetup is just focused on Azure, and that's what we've been doing since about 2013. Like I was saying earlier, I took over this group in about 2015 when the leader of it moved to Florida, and so I pinged him and said, "What's going on? I haven't met." Oh, well, I've left. I want to take it over. So I've been running it ever since, and it's been a very, very, very fun hobby that I enjoy enormously. So, all right, and a couple of things this group is not. So if you're here for like a sales pitch, absolutely 100% the wrong place to be. There's not going to be a sales pitch there, and if you're here to sell to someone or be sold to, again, you're in the wrong place. This is about learning from others. It used to be very much Houston centric. In fact, we didn't even used to do virtual to encourage people to show up in person. Things have changed. Now we're virtual. We've had folks come in from Australia. Andrew, I don't know if you're on the call tonight, but we've had a frequent visitor from Australia join us, so that's all good. Yeah, there he is. In Perth. What? A warm welcome. What time is it in Perth, Andrew? Just because we're wondering here in Houston. Well, I guess we can bingle it. It's fine. It's probably, no matter. A warm welcome. Thank you for joining. 8 in the morning. That's not too bad. No, that's not too bad. Not too bad. So, all right. Glad you could join us. All righty. So, a little bit about enough about me and the group. So, a little bit about tonight's speaker. All right. So, again, like I was saying, tonight's speaker is myself. So, this is a bit of an indulgence for me, frankly. So a little more about myself then. So I've been working with cloud. I got my AWS account in 2007, and I was at the launch of Azure in 2010. and working full time. I was initially the cloud strategist for Halliburton here in town in 2013. Was my first full-time cloud position, and did that for a couple of years before coming back to Microsoft for the role that I hold currently. I'm a cloud architect, helping mostly enterprise customers, of course in Houston, so mostly oil and gas, but not always. Work with some FinServ folks as well, and some healthcare folks actually. That's been interesting. So the variety of folks on the cloud since 2015. So rolling on 7 years in this role. So tell you what, I've seen a lot of cloud journeys. I've seen them all, many from beginning to end. Those who are just, okay, we just got an Azure subscription and this is, okay, help. And others who are like, yeah, well, we don't have an on-prem anymore. We had an on-prem, we had a colo, it was fun, it was great. We've exited it. So it's all in Azure, that's awesome. It's too expensive, we need to optimize. Help. Okay, yeah, absolutely. So see it all, beginning to end, and everything in between. So it's a lot of fun, and again, I have lots of stories, and many of you know I like to share those, and we can chit chat as questions come and go, particularly around some of the topics that we talk about. But you know, in this particular presentation tonight, this one is, as a longtime member Mike called out, those of you who have come to these meetups frequently may remember one that we did with the Texas group that I did, because it looked interesting. It was on Postgres, I think, as I recall, which so that sounded like fun. So we partnered with the Texas group. And in any event, the presenter had this kind of cool demo using quite a cool gadget that I thought, oh, that's cool. I want one of those. And anyway, so I got one, and I've built a whole little solution, which is something that going to show everything I've built, and we can put together in my spare time for funsies. And we're going to go through that today. So without further ado, let me first show you my little so the business case, if you will. So we're going to do like this. Alrighty. So what we have right here is a black box, everyone. It is a black box. This is a photo of my black box, actually in situ, as it were. You can see it is actually, and so I'll go into the details of what this black box actually is later, because it's interesting. But again, I'm trying to walk through like a business scenario right here. We're looking to solve some problems. So this is the black box that the business purchased. You can see it seems to be installed in what looks suspiciously like somebody's attic. Kind of is somebody's attic. It's my attic. In fact, it's overhead running. I can't show. That's why I can't show a picture of it. You can see it's cabled in, and it has some mysterious-looking orange gadget in the back right there. There's another picture of it as it came when the business, me, ordered it from eBay. So anyway, it showed up pretty much like this, and the business assembled it and plugged it in and put it together. And so so we have some weird orange device here, does something or other, and this blue thing here, not really sure what this hardware is. And frankly, for the purposes of our discussion tonight, don't really care. I don't care what it does. And so what we also have on the end of this, just FYI, right, to just complete the picture, is to help understand at least what the business case is actually an antenna. So we've got some coax that you can't see coming off the left right here, which runs for, I don't know, 20 or 30 feet or so to the highest point in the business's location, which is in fact the house. So all right. So let's see, what do we do with this guy? And so let me just get in. All right. Okay. So what does this gadget do? So this is our on-prem, right? This is on-prem, and hopefully you can see how this might map to some real use cases, is obviously the intent. All right, so on-prem, we have, what does this gadget do? It actually, here we go. So this is the output of the black box, the gadget, if you will. So kind of cool. This is what the business wanted to do with it. And so it turns out this black box is looking and listening to overhead aircraft signals and notations. You can see that I'm still 100% on-prem, not a single piece of Azure or cloud at all. We are all 100% on-prem at this point. So this, I've got my browser right here on an insecure protocol, HTTP, connecting to a port on my black box right here over my internal home network, which returns this user interface, which is served up by our black box. Okay, kind of cool, kind of neat. And you can see that these, that has this little map thing. That's kind of cool, and shows various aircraft moving about. You can see, kind of neat. Okay, didn't build any of this, right? The black box I was describing does all of these things, all running on-prem. And you can see it updates. I can see some updates here. It seems to have some information like the flight number. Neat. This squawk turns out to be, upon reading the manual, an identifier that air traffic control used to identify an individual aircraft. And then, the current altitude, how fast it's going, and the distance in nautical miles from the black box. As you can see, marked with a little dot there. That is the on-prem. That is our colo right there, which looks suspiciously like an attic. Okay, there's our on-prem colo. Here's some data, and basically everything's working just fine. And this is great, fun and dandy. Okay, so business problem then that we've chosen to devise for ourselves using our black box is we wish to know when one of these aircraft flying around, any aircraft at any time, goes within, whenever it flies directly overhead the colo, right? And so imagine a cone, not a sphere. We could, that's not doing that for now. Imagine a cone centered on the on-prem, the colo, our black box, if you will. Imagine it an arbitrary distance wide, let's say 100 meters. Going to pick that for reasons we will see in a little bit, actually. In fact, that's what the business has picked, 100 meters. A cone, so 200 meters in diameter, 100 meters in radius, infinite height. When a plane flies within that colo, we want to know that that's happening. So that's our real-time eventing use case that we're looking to explore and try and figure out with our black blocks right here. Alrighty, I know for a fact that there are some devs on the call here tonight. Does anyone have any suggestions how we might go about doing this off the top of your head? I've disabled cameras, but mics are allowed. Any thoughts? No suggestions.
Could you repeat the question one more time? Sorry, could you repeat the question one more time?
Yes, Mike. How would you solve this problem?
Like the actual problem, just to ingest this particular data, right? We would not stream them into one of the many Azure services available, like maybe an Event Hub, and then we consume that through some Azure function or some other solution and log them into a database, and then from there we parse them through. When you said there's a requirement for certain radius, right? They enter a certain zone, and we probably want to parse that to some kind of geo API, and then get the result if it's within that or not. If it is, it triggers our next trigger.
Yeah, all those things sound very plausible. I'm sure we could figure out something along those lines. And in fact, some of those components are indeed the ones that we're going to be using or showing and talking about tonight. First off, how are we going to get the data off of our black box? Any thoughts? Mike.
And what's the box is just sorry, I actually missed a little portion of it. I was trying to grab a drink.
I understand. It's over lunchtime. You're multitasking. It's all good.
Is cloud connected, right?
turns out it's connected to the local network, actually, is what it is, and that it's a black box. So that's really all we know about it.
And does it have internet access? It does, right?
It does. It can see outbound on the internet. Yes, yes.
If it can do outbound internet, and it can definitely become a event sender to one of those hubs.
It could. Hang on a second. Oh, that's not what I wanted. I wanted to do. Yeah. So all right, I'm going to give it a hint. So I read the manual, and turns out we have some capabilities on our black box. Let's make sure this comes up. Go. All righty. Read the manual, because that was, of course, the first problem, because we're 100% on-prem right here. When I've brainstormed this with others, other folks have suggested, can we, hang on a second, I had a picture, where's my pictures of it? I'm going to close my pictures. The pictures of my little box, can we shell into it? Can we, maybe hack the data on this thing? Because, we can see it must have the data on here somewhere. And so, no, we're not going to hack into the box that you just saw. Not going to do that. In theory, maybe we could, because we can, in fact, turns out, shell into the thing. It's just a little box. It's on the network. So SSH on this guy does in fact work. But no, we're not going to do that. Let me. So what we did
Adam,
find.
does it have a REST API service on it? I know a lot of these special devices have that, where you can make a REST call to it.
All right.
A data pull.
Okay. So yeah, I read the manual and I found this. So this is not quite what you just mentioned, right? It's not quite RESTful. In fact, it's not RESTful at all, as it turns out, unfortunately. In fact, it's a little more primitive than that, because we don't want this problem to be too easy. If it was too easy, then I mean, we wouldn't have anything to talk about. We'd have just clicked a few buttons and we'd be done. So no. On the other suggestion that folks had was okay. Before I show this, I meant to indicate, hey, this data, how do we screen scrape this? Can we screen scrape it? So yes, we could screen scrape it, right? Because this is just an internal, particularly if you're developers, then we could view the source on this guy. It's just some HTML, right? We can just pull this and screen scrape, because there's some data on here, and yeah, could do that. Really, really ugly. And so that's where I intended to get on. RESTful APIs is what took me to this. No, there aren't any RESTful APIs, but yes, we do have this little guy here. Can you everyone see it? Okay, is it big enough? Make it a little bigger. There we go. So all right. So if I just hit refresh here, interesting. Seems to be some what looks suspiciously like JSON. Refreshes every second, as it turns out, pretty much. Yeah, there we go. And you can see it's the same page, right? So there's no API. It's always this aircraft.json. So, but just doing a refresh, I'm just punching refresh on my browser right here, just means that okay, I have some data, and so alrighty. And again, reading the manual a little bit, I had to look up some of these things. If I stop hitting refresh for a second, this turns out to be a as hinted at by the text here. This is the time. It's actually the number of seconds since January 1st, 1970, Linux timestamp, basically. So that updates. So that's our current time, basically. And then I'm not sure. This is from the manual. Not really sure. Number of messages that we think. Something to a device. Not really sure. But getting back to the business problem, right? We're looking for data in here that can help us. Hex, don't know. Alt baro. All right, that turns out to be the altitude barometric. Quite nice. And then alt. So here we have the altitude. Okay, well that's cool. That's interesting. If we had the business case for a sphere that I was describing from on-prem, wanting to know just for funsies sorry, not for funsies, because this is an important business need that we're looking to solve here. Then then we might care about that. We could just figure out how high. We could calculate whether or not this aircraft had entered our sphere by accounting for height. Initially, this run through, we're not doing that. Just like I say, infinite height sphere centered on-prem, right? So, okay, track, don't care, geometry, don't really care, squawk, don't care, emergency, no, altitude, no, don't really care. Okay, nothing useful there. Okay, what we're looking for is some GPS coordinates. Oh, there's some. Okay, lat and long. So a couple of things we can see here does seem so that we've got some data that has a latitude and longitude that suggests that, okay, 29 point something minus 95 point something, plotting that into Google Maps or something like that would give us a latitude or longitude not far from on-prem, as it turns out. If anyone feels like it, you can punch in these numbers and see where this particular aircraft is. So, okay, so I think we're starting to get towards some data that could be used potentially to answer the important business question of has this aircraft entered our sphere of 100 meters from on-prem? Oh, and incidentally, we can use our phone here in order to locate the exact location of one's chair the center of colo on-prem. So that gives us our source, and we have latitude, longitude, and our destination. So as you can see, we have a promising looking solution here. And those of you who are just developer nerds or just nerds like me, when I first saw all this cool data, I was like, oh, it's cool and it's fun as all get out. Turns out it is indeed fun as all get out. Anyway, back to seriousness of solving our business case right here. All right. So a couple of interesting challenges that we quickly discover with our data right here is that it's uneven and it's dirty. This data is not very clean. So it's missing some things. There is a schema. There is a schema, it turns out. But we can't depend on this data being in here all the time, every time. And so it's missing some stuff. And as you can see, each of these entries right here, there's one. For example, this particular one does have latitude and longitude, but as you can see, this one above it, this one here, which is also, as it turns out, upon reading the manual, each of these lines is an aircraft, an aircraft that our black box has spotted in the air overhead from on-prem. And turns out, upon reading the manual, that the further away they are, the ropier the data, and also some aircraft do not transmit a complete set of data. Private aircraft, sometimes they just block it. I mean, it can vary, it turns out, right? So can't depend on very clean data right here. We have some data and we have the answers we're looking for. So what is next? How do we get this data and what's next? So this is what we've learned. What can we do with this team? How would we solve this problem? Particularly if you're developers, if there's any developers on the call, how do we solve this problem given what we know so far?
So the data has to be retrieved on-prem, right? You said so. We have to host some sort of device on your local network to pull this data.
That is correct. This is 100% on-prem. That is where our black box is, the one that we saw on the colo a little earlier, that looked suspiciously like Myatic. So yes, this we do indeed have to stay on-prem in order to retrieve this data somehow.
Correct. You could do it in Python with a get and post. You've got those libraries. You just load them into your code.
Yes. Yeah, you could. You could do it in Python. You could do it. You could run it.
PowerShell too.
PowerShell would do it. Yeah, has a command. Because as you can see, this is a little black box. Evidently, has a web server on it. Because we're just using a web browser, just using HTTP to retrieve our stuff right here. So yeah, any language that supports HTTP, nothing fancy. As you can see, it's not even HTTPS, so it's pretty basic. So relatively easy.
So
that's right.
Console app will just on any computer just do pull this at a interval. By the way, how fast are they updating? Do they dump this data in every second, every half second or something?
That's a good question. So some poking around and some general testing will show us, because the manual didn't mention this, that it's basically written every second or thereabouts, about every second. Once every second, the file, this one here, aircraft.json, it's overwritten. And there is, incidentally, in case you are, there is no storage of any kind. It's not stored or persisted anywhere. This file is overwritten every second with, as it turns out, whatever the black box could see in the air at the time. And that's it. It's not stored. This is the storage, and it's lasts for 1 second.
Is the black box capable of sending the events in a stream to some sort of like IoT hubs in the cloud?
Oh, wouldn't that be great? No, unfortunately, it's not. It's not. Now, it does have a proprietary, and again, I'm brainstorming with other folks on this exact thing. It turns out it does have an interface that's actually on the. So we have this website right here. Turns out there is like a public website, and one of the jobs of this black box is to send this telemetry to an external website. It's actually called this flightaware.com. I've had folks saying, "Hey, we could intercept that. Can we hack that stream? Can we get the data?" I mean, it's being sent up to these FlightAware guys, right? And it is. I won't show it. It's not important. But yeah, it is being sent to flightaware.com, or the telemetry's there, and you can see it. And they've got an app and whatever. Can we get the data from there? And the answer is yes. Yeah, we can. They actually do have a feed. We have to pay for that. That's actually stuff that costs money. So we're not going to do that. But in terms of like event hubs or streaming from our black box, no, it is 100% proprietary for our intents and purposes on solving this problem today. It's proprietary, so no, we can't hack into the box. If it uses Azure, we can't see it. We don't know what the thing does at all. All we know is that it does spit out our little text file right here. This is it. Although like I say, it does evidently talk to its own cloud somehow, some way. We don't have access to that.
So it has to be a tool.
There are websites that provide a service for monitoring for changes in web pages. I don't know what time frequency they can do it at, and also what networking would be involved to expose that page to a public internet service like that. So it's a thought.
Yeah, not a bad one. I mean, yeah, there's no bad ideas right here. We're just brainstorming. There's no particular one solution necessarily. So yeah, the problem with that, of course, is that this is behind the firewall, behind the corporate firewall, right? So we would have to figure out a mechanism to proxy this and expose it somehow, or some firewalls, something like that. Could be done. That would allow us to track changes on this site. In fact, to retrieve the data, we could use that mechanism to actually fetch the data from this page. So yes, that is one way.
Not just the fetching, but the turning it into a stream of events. But and obviously you could roll your own.
You could, yes, which is what others have suggested, right? We're going to roll our own. We're going to build our own thing, and that's all these things are possible. So yeah, we have a couple of things. We can go and fetch it from a cloud from somewhere else, from Azure, a VM running Azure, fetch it somehow, retrieve this data. Yes, we could do that. Some complexity involved in the networking. Not sure. We've got some risk involved because we've got to poke some holes in the firewall. We've got some inbound connections right there. So we got some risk and some networking connections. Our cybersecurity folks might not be too thrilled with opening firewall ports in all to that. So I anticipate pushback from our cybersecurity folks on-prem about poking holes in our firewall and retrieving that data. So that's problematic for that reason alone. Technically possible, but problematic because of from a risk perspective. Don't like inbound connections to our on-prem like here. Want to discourage that unless there is any other way. Other thoughts?
Is coding preferred, or it's to be avoided?
That's a good question. So yeah, okay. I guess the answer to that depends a little bit on the available skill sets, right? What we're able and feel comfortable doing. If if we're able to write a little code, then that would be preferable, I think. So that's that, and I'll share. That's the way I solved it. I wrote a little code or script, which were the things, a couple of things suggested. So Python was one suggested. PowerShell was also suggested. Both of those are script/code solutions, if you will. The alternative, of course, is all infrastructure based. So I think, was it Andrew that spoke just then? The retrieving the data by poking a hole in the firewall from some service would negate the need for writing any code, which, if we don't have any coding skills available, then, or any coders to help us with this, then that could be approach, and perhaps that's the only one. Perhaps that's the right. We're not.
Since we're talking about the Azure, services, I wonder if there's like Azure services that can read the URL and keeps putting the data into some sort of a staging area. I've done similar stuff with the web clicking, client journey data. You have there's just some sort of a services called segment that you enter that URL whenever you click on the website, that it's automatically like a live stream to pull all the data from the website. I wonder you have some sort of service can tap into this URL and stream the data right into whatever Azure services.
Yeah. There are, in fact, some Azure services a little bit like that. And so those, I think, and those are the ones that I used for this. But we're brainstorming possibilities. So I think you're on the right track. But I wanted to highlight some of the problems or risks with the other alternatives, right? Because there's no wrong answers, but there are also problems with these other solutions. I highlighted the security risk of coming in through a firewall and pulling it up. And custom code like PowerShell or Python, what are we going to run that on? So I have a suggestion. I'm going to turn my camera off a second. So here, let's see. Here we go. Can you see this? Yeah, there we go. These little guys right here. I mean, it's a little blurry. Let's see if I can get my camera to focus on it. There it is.
Pack of raspberries there.
These are indeed, this is a Kubernetes cluster running of 3 Raspberry Pi devices. These are Raspberry Pi 4 devices, in fact. So you can see they're plugged into USB-C, and on the other side we have heat sinks, a little CPU, and full, get the camera to focus on that. Get some length on my cable right here. Try to unplug them. Yeah, so you've got network and USB on my little devices here. So I can plug these guys into the network. And so, yeah, there we go. So this is a pack of 3 of them that I wanted to show. So this little device is a handy solution for running code on, right? So we could run some code on this thing. Turns out these little devices, 64-bit ARM processors, reasonably quick, actually. And I think these ones, I got these with 8 gig of memory in them, and an SSD to run the OS on. So I think I went for a 256 gig OSD, I think. So I don't know, relatively decent little machines. So on these little gadgets, or one of those, right? This was an example, and I'm not using these. This is not part of the solution. This is just an example. I'll show how I used one of these as the solution. I just wanted to show you the little device for anyone who hasn't seen it. So this is a great platform for running, like some custom code. We could put some Python on this thing, right? Maybe a cron job could pop up and go and fetch our data. That would work, right? Just using HTTP, we can get that, or PowerShell. If PowerShell is your thing, PowerShell is open source, so that would work. These run Linux, so yeah, I could Ubuntu, in fact, on these guys. Yeah, we could put PowerShell on here and script it. That would be good. If we were using Windows on some Windows machine, in fact, this cluster actually has a Windows node on it, for reasons I can go into later. I can't see it. It's not a Raspberry Pi. I have a little x86 little box that runs actually runs Linux, but it could run Windows on it as well. I could have that as a node on my AKS cluster. I could have that running Windows and create a Windows service and write some .NET, some C#, something like that, language of my choice, or Java that runs on either and do the same thing. Go and fetch this data. All those are valid solutions. How are we going to monitor the thing though? Because that would work, right? It would. We could get that to work. How are we going to monitor the thing? How are we going to update the thing? How are we going to see how it's doing if we're not on-prem? And what if we need lots of these? Maybe the business wants lots of these things. How are we going to handle that? How are we going to update it? How are we going to update the code on this thing? If we can't, because unless we have some kind of a solution, then we're going to have to do it all manually, obviously, right? We're going to have to write the code, put it on there. We have to shell into the thing, update it, and see it, and all of those things, which I don't know sounds a little bit like hard work. And the IT directors thinking that's kind of difficult and hard work, and so I'm really lazy, so I like things that are nice and low effort. So okay, that leads us to desiring a more automated solution than that. So the solution that I went with, unless anyone has any other suggestions or thoughts before I share the way I solved it.
Just wondering.
Yeah.
The operating system. I mean,
Yeah.
And you said that there's no storage on it, right? But
on that black box, Timothy. The black box,
yeah.
It appears to have some storage. It appears to run Linux as it happens. It turns out our black box is actually a Raspberry Pi 3. I recognized it from some pictures. It's a Raspberry Pi 3 running Ubuntu. In fact, it's running Linux. I forget what. It's not Ubuntu. I think it's it's a flavor of Linux made for the Pi.
So there's an old school command called tail.
Oh yeah.
I mean, couldn't we tail the file and pipe it to or send it to like a text file where we can kind of retrieve it from there, something like that?
Yeah. So Timothy, your suggestion is similar to the one that we were bouncing around. Like we could use Python on another computer we've got lying around, right? And these Raspberry Pis I was showing are nice and small, so those seem like a good fit. But some old laptop maybe we've got. We could, and like you're saying, we could do a tail in order to fetch the data and store it somewhere on. We have to fetch it from our black box though. That's a key consideration. We have to go and get it. We can't get on our black box and mess with it because it's literally we can't touch the thing. It does its thing. We leave it alone, so we have to fetch the data and store it somewhere, and then get it into the cloud somehow. That's the problem that we have. And like I was saying, we could use tail. That would work, or we could use Python, or we could use PowerShell, or C# or Java, whatever we've got, whatever we know, in order to fetch the content just via HTTP, store it somewhere, and then how are we going to get it into the cloud? And so
we don't store it. Why don't we just run for each? In the most basic example, we just for loop it, and you said every 1 second is when it updates, right? So we run it every 1 second, retrieve the data, and there's some language that has some nice JSON handling. Even if it doesn't have a schema, we can serialize it, and then just use the SDK to directly send it to Azure within that same loop.
We could again. Not a wrong solution, right? I'm not shooting you down. That's something that could work, and we could fetch it from HTTP, and we could send it via HTTP as well. But that leaves us still with the couple of just operational problems, right? Operational problems. How are we going to get the code onto the box? How are we going to update the code? How are we going to see the status of the thing, right? If we're not, actually logging into it, because we don't want it. Because remember, I'm lazy, so I don't want to have to log into the thing. I want to see how it's working. I want to see how my code is running without having to actually shell into the thing and read the log, because I'm lazy. So all of that leads us, right? Again, none of your suggestions are wrong, but the reason that the solution that I went with is because of those operational problems. Solution I went with. Yeah, go ahead.
Sorry, you're about to tell us, but
no.
I haven't used Azure Arc a lot, at all actually.
Okay.
But when you said you pointed out that you had a little cluster there in your hand a few seconds ago.
Yes.
And you pointed out the operational problems, because honestly, my initial inclination would have been run a local service and then, you know, scrape or get that data and then send it over to an event hub, and then it's in Azure.
Okay.
But since you've got a cluster in your hand, why not leverage Azure Arc to work with that cluster?
I could. So the purpose of showing my little AKS cluster here was just to indicate for anyone who hadn't seen a Raspberry Pi, just the little devices here. I've got 3 of them, and the fact that they're a cluster is coincidence. And so we could use that, Terence. What we're trying to do here is make lives simple for ourselves and not unnecessarily complicated. Remember how lazy Adam has admitted that he is here. So it's again, not wrong. We could stand up in all those solutions we're talking about. We could have, we could write some code, put it in a container, load it on our AKS cluster, and we've got some resiliency there, which actually is quite good. For those of you who don't know what Azure Arc is, I should speak about that. And actually, I should speak about Kubernetes real quick, a way of managing and storing containers, Docker containers running custom applications. That's what Kubernetes is, an open source solution, native to Linux. So although you can have Windows nodes as well, and it's a way of hosting those container workloads and has handy dandy things like being able to spread those applications across different nodes. So I could write one application and Kubernetes would spread it and run it across all 3 of my physical node right here, which is quite handy dandy and quite nice. And I could use that for all of the solutions we were just discussing using custom code. Reason I'm shying away from that one is just that's a lot of complexity just in order to fetch a single piece of code right here, right? So I could trying to keep it simple, not over engineer it. I'm a fan of engineering it, but we don't want to over engineer it because again, operational complexity, right? Kubernetes, it's actually, this is a bare metal one, so it takes a fair bit of care and feeding this thing. So I've got 3 pieces of hardware, and so my on-prem is kind of filling up if I start getting into Kubernetes in order to solve this problem. Now, I happen to have one, and I could use it. And if I had a whole bunch of other workloads that were doing other stuff, maybe related to this problem, maybe not, then actually Kubernetes might be a good choice for a hosting platform. It can do a whole bunch of other stuff and this. That might be quite a neat solution. Doesn't help us, however, in a couple of critical areas. Number one, well, I mentioned operational. So Azure Arc, which is for anyone who not familiar, is a way of controlling and viewing your AKS cluster in Azure, which is quite nice. You run an agent on your physical on-prem device, and then you can see reports of it, and you can apply policy, and you can even enable DevOps to it and use it to update your code, which is cool, which is good. What that doesn't help us though is intermittent internet connection. So remember, we have a real-time solution, eventing solution here. So what happens if we have intermittent connections from our on-prem? It just goes offline, you know, and obviously our device is on-prem as well, so it's going to keep on working, right? It doesn't, as it turns out, doesn't need the internet in order to work because it has an antenna, a physical antenna. So as long as it has power, it can see and track all the aircraft without any internet at all, and it will update and write data to the file we were showing earlier, and that works just fine, even without the internet. So the internet requirement is for us. We want to get it and store it somewhere in the cloud, right? And Azure Arc doesn't help solve that problem. And any of the coding solutions we were just discussing, we could use PowerShell, C#, Java, any of those, cron jobs, tailing, monitoring the thing. None of those solutions help us with intermittent internet connectivity issues. That's actually something we need to code for. We actually need to deal with that in our code, as well as monitoring and updating all of these things. So, all right. So again, none of those solutions are wrong. You could all get them to work. As you see, it's a relatively simple task. The solution I went with is using IoT Edge. IoT Edge is a service that comes with Azure that extends a service that runs in Azure called IoT Hub. And so what this allows us to do, among other things, is upon a Raspberry Pi, that was why I was showing one, just one is all we need, install the IoT Edge runtime, just a set of command line tools that install upon it. And then we can write some code that in languages that any language we like, we just put it in a container, essentially, because IoT Edge will take a container-based workload and run it locally on the device we've installed it. Like I say, I chose a Raspberry Pi because it's small and frankly it's cheap, but we could use whatever we want. IoT Edge runs on a lot of x86 or in this case ARM86, right? So I installed IoT Edge on that guy and hooked it up to Azure, wrote some custom code in a container and it put it in a container registry, pulled it down, and it runs on my IoT Edge device. The IoT Edge device is physically connected to my on-prem network. It's in on-prem, and my code uses straightforward ATP requests, just like everyone was suggesting we do, in order to fetch this data. But then it uses the SDK that comes with IoT Edge in order to send the data to the cloud. And that's where we get the extra features and benefits of the thing that are kind of handy dandy. So let me show some code, because we did talk about, do we need to write some code with this thing? Turns out, yes, we do. And or at least in the solution that I went with. So it's get my screen ready and then share this and show the code that runs on my IoT Edge device. So just for folks, so stood this up. Okay, let's get like so. We'll just walk through what this does really quickly. Won't get too into the weeds because, you know, not everyone's a developer, not everyone may care, and that's fine. So we're just going to wave through it, trying to indicate one of the reasons why we went for this, in preference to those other valid solutions, right? That why this helps, right? Why did we go to the extra effort of using this IoT Edge thing? It doesn't cost anything, incidentally, but it's a bit of extra effort, right? And we're sort of locked into using this particular service as well. So let's talk about that. So okay, here is my code. I wrote it in C# because that's what I happen to know, but it really could be anything that I could for which there are SDK support for the IoT Edge SDK support, and that I can put and build in a container. So as you can see, just in my code, notice that I'm using some extensions as part of IoT Edge. I am using a simple time span to basically fire this every second is what I'm looking to do. I'm using some concepts to when this launches to kick it off, that IoT Edge will keep an eye on for us, because it's keeping an eye on this application, and it will restart it for us as well if it fails, and I can also remotely start and stop it. So I have some extra code in here to handle when that happens. And then my init method here has to be called this because IoT Edge is expecting this. I pull some configuration pieces here, and then set some transport, and as you can see, I've basically hard coded in the very same URL right there. Just make sure my fat head isn't blocking the view. So as you can see, straightforward enough. That's the URL that I'm going to get my data from. Create a module client asynchronously, and then this call this send aircraft data. So this guy is going to basically grab my message right here, add some properties and data upon it. I'm going to do a little bit of data cleaning right here. And this is one of those things where, you know, I could do a lot. There's actually a lot more I could do on my IoT Edge right here. So just an indication, I'm using some code here to basically see, I'm calling this actually, I think every 0.7 every second or thereabouts. And I'm trying to avoid some duplicate data. So I fetch this thing, and sometimes the timestamp, I want to make sure the timestamp is different. Because I'm just going to go get it all the time. I'm not trying to be smart about it and make sure, or I'm just fetching it. And what I do is I compare the timestamp. I keep a record of it, compare the timestamp, and if it's the same as the last time I fetched some data in here, okay, never mind. It was a duplicate. We'll just skip that in order to try and minimize, improve the quality of the data. Add some custom data to my stuff right here. Some of it pulled from the message. I put an actual timestamp for some unknown reason right here, because I realize I actually have a timestamp I have a timestamp, but it's in the wrong format. It's in Unix timestamp. And so in case I wanted a timestamp that is an actual fully qualified date time as a string, there it is. I put one in. I just build one and add it to my properties. And then I use this module client, which is nothing to do. I didn't have to write any of this. This is just native components to IoT Edge right here to send an event. Just go away. Just send it, and it disappears. And I don't have to care very much or do any configuration in my code right here. I can trap and do some errors and send this telemetry to some monitoring services I have in Azure. And that really is all the code that I need to do. So not a lot of code, just as everyone suggested. Everyone suggested this is pretty easy to just to write a little code. What I've also added here in here is the ability to get it off of my device right here, right? So some folks were suggesting we can just use HTTP to call some RESTful APIs in Azure. Yep, all the services in Azure expose RESTful APIs. Absolutely, we can call those. But what we really need is a messaging service because of the problem of the internet going down. And this, using this approach right here means we have a queuing system native to the service that will just back them all up. And retry all behind the scenes without having to write any code until such time as the internet comes back up, and then it'll send them all. All right. Any questions at this point as to the on-prem solution to getting the data from my on-prem black box?
If you update a code, if you update a container in Azure, it automatically gets pushed to your device. It doesn't have to, like, basically this is the maintenance part you're talking about, right? You don't have to get networking, some sort of networking done to hook into your on-prem network. You can just all do this from Azure.
Good question. I can do all this from Azure, yes. What I'm showing you is my development environment locally. I would then build this, and I've got various, depending on the technology, in fact, of my IoT Edge device. You can see I've got a variety of options here that come with the SDK for IoT Edge, depending on what it's running on, right? I'm running on AMD 64 right there. So that's the one that I'm using, or AMD 64, that's my production, target, if you will. And so I build my code here, build an image, and I push it to an Azure service. So it gets pushed to an Azure container registry in Azure. That's where the container is. And my IoT Edge device, as part of configuring and setting it up, goes and fetches my container and pulls it down to where it's running on-prem and pops it up. If I want a new version of my container, I can whatever build process I'm doing, and from wherever I'm doing it, I just push it to the same container registry. And then I can, from Azure, tell my IoT Edge device to go and fetch the new version. It doesn't do it automatically. It will do it when I tell it to, however, and I don't have to be on the IoT Edge device to do it.
So the IoT Edge, is that you're using the APIs there to do the data cleanup, or you're using something else to do the data cleanup?
Good question. No, I'm just using my code to do a little bit of data cleanup. There's no help from IoT Edge's SDKs for the data cleanup here, to be clear. This is just a little bit of code that I wrote, just this little if statement right here, for example, it just checks to see whether or not the last time I ran is the same as the time I'm running now. That's just my code. There's no help from IoT Edge here. I could have done that without IoT Edge at all. This is simply an opportunity to try and save me work later on, right? Because the quality of my data is a problem, and I could have done a little more work on my device right here. I could have done more cleaning, could have done more parsing, perhaps. In fact, there's quite a lot of things that I could have done on my IoT Edge. It supports cognitive services running locally, so I could do some artificial intelligence work on my IoT Edge device. I didn't need it for this use case. Could have done that. I could also do a service called Stream Analytics, which is one that we're going to see a bit later, which is a very powerful service for doing the data cleansing. And I could have done that on my IoT Edge device as well, which reduces the burden of the work done on the cloud, and in particular means that I potentially have less data to send, so I can do more cleaning with additional services running on my IoT.
Yeah,
Edge.
I see that. And when you scale with these things, you want to keep that traffic down, but also there's less work to do in the cloud too, because there's less data to process.
Right. Exactly. Yeah, going to have to clean it at some point, right? Someone's going to do it, and we're going to need to do it. We're going to need to do it somewhere. And so having this here gives us the option of doing some, or maybe quite a lot on the IoT Edge device. I chose to not do that much. I'll show you where I ended up doing it, which isn't necessarily the right way, right? It's just the way I ended up doing it. I could use my IoT Edge device, and that some of that depends on the horsepower of my on-prem device, right? This is just a little Raspberry Pi 4, not that much horsepower, but actually enough to do more than I'm actually using it for. It's actually quite a little powerful little gadget, honestly. So I could do more with it. But if I had a really low power device, I mean really low power, then maybe what you see right here, maybe this is all I'm going to be able to do. I need to do a little bit of processing and then just send it, and that's all the horsepower on my little device. If I'm very space or power constrained, for example, so real world use cases are, of course, here in oil and gas, the oil field, right? Very low power location is the oil field. Very electricity constrained locations. So all the devices on the field have to be very low power. So low power equals low performance, usually. Maybe low quality power as well, and definitely very intermittent connectivity. So you might be very constrained on the physical size. You're also not only power constrained, but your size constrained. Not much room in the control boxes in the oil field, typically in remote locations. So have to be very, very small, very, very low power. So you may not be able to do a fat lot more than that on a device that would comply with those requirements. If we have a little more oomph available to us, an old laptop maybe, for example, then we could do a little bit more with our IoT Edge device right here.
Does the IoT Edge buffer the incoming information into a mini batch and send it, or can you set a window of how long you want to buffer the streaming, the events, and then send it to Azure for further processing?
It does buffer it. That was one of the solutions to the internet connectivity problem I was describing, and that's one of the reasons for using this. We're using a service in Azure called Event Hubs, which is a data ingestion service, and the SDK with IoT Hub that we're using right here natively talks to it. It's provided as part of the service and offers some of that data buffering capabilities without us having to do any work. So we just use the SDKs that are provided, and the IoT Edge runtime basically figures most of it out for us. If that helps. Now, how much it buffers, the configuration of that, I actually don't know. I think there are some options perhaps, but I have not explored those. I'm just going with the defaults. You see my code right here. I've not picked a whole lot of options here. I just let it do its thing right here, and I catch any errors that happen. But most of the time, I just let it do its thing, and in my experience in running this thing, it just has. So perhaps we have
about missing
on...
schemas. Like you said, there could be missing properties of some of these data. So I
Yes.
guess on that deserializing code there, the class, you just build one with all the properties you're interested in. And if it happens to be not available, it's just now, not a big deal.
So here, let's see, I am, this class right here. So I do have a class with this aircraft right here, which, yes, as you see, yep, just all the properties, everything possible. So these will just be null if I want. Yeah, so missing properties is a problem for further upstream. Like I say, if some of these that I was expecting, so the ones we care about, right, are going to be well, I'm looking for, why am I not seeing okay, sure. Missing something. Well, okay. If there are properties in here that we care about and they're not in, then I could deal with it in my code right here and do a bunch of extra processing and data cleansing, and also I could save myself some work by ignoring messages that didn't have the data that I want. I could just not send them in my code right here. That would be good. That would mean I have less work to do in my code and less messages to process in Azure. So I could make that optimization. Yes, that would be more code. So again, the reason I didn't do that is because I'm lazy and I didn't want to have to write too much code. So even though I'm a developer, lazy developer, so the less code that I have to write, the less bugs there are going to be in it. So as you'll see, I'm trying to use more native solutions to save me work on that. But I could have, to your point, right? I could have gone to the extra effort of writing the code here, which would have meant sending less data. So there might be some business benefits to investing a little more time in cleaning the data, only sending messages that I care about. Another reason for not doing that, just pretty much sending everything, is that that means that I then have the option of solving and changing my mind about what I care about later, right? Rather than locking myself in right at the edge here and potentially throwing away data that maybe I actually care about. I actually, you know what? Change of mind. We actually care about that. But, well, we wrote some code and tossed it because the business requirement was throw it away. So we wrote lots more code and we threw it away because that was the business requirement at the time. You're saying the business requirement changed. We can change the code, but you shouldn't have made that business requirement back in the day because we wrote the code, we tossed the data. So in anticipation of business requirements changing, we're not going to throw anything away. We're just going to basically send everything and store it as well. That means that if we change our mind later and the business want to see some historical things for things that we would have thrown away in the past, we've not shot ourselves in the foot, if you will.
Hey, Adam, as a C# developer, and since you mentioned you want to write as little code as possible, those 4 lines of HTTP client calls can be reduced to 1 line with a newer .NET's extension method on HTTP client called get from JSON async. So we'll basically grab that, serialize it in 1 line. Okay.
Yes, please send me that optimization because I'm lazy and I would like that. Didn't know about that. That sounds great. I'll make that change. Thank you, Mike. Oh, there it is. Beautiful. Nice. Okay, I'll make that change. Yes.
Another thought. I really like this solution. I've learned about a new service, which you'd think I'd already know about IoT Edge.
Not necessarily. It's all good. I learn
But
things every day.
when we were talking earlier, I don't know who it was. Maybe Andrew mentioned calling a service, and you pointed out, having to poke a hole in your network. And so
Yeah.
I wouldn't call this poking a hole, but maybe let's level set on the fact that there's still some network administration to enable this.
There is. This is much less onerous, right? And from
Yeah,
a
agree
from a
100%.
cybersecurity perspective, this is a network connection initiated from on-prem, right? So it's initiated from on-prem, and the network connectivity that we're using here, it turns out it's not visible right here. Can't see it. Can't see the network connections because it's a black box, and we just do it and away it goes. Turns out this is all HTTPS outbound connectivity, port 443. So it's TLS enabled, and it's a nice friendly, no TCP ugliness that our cybersecurity friends might not like. So that, generally speaking, and again, enterprise customers in general, okay with outbound HTTPS when the connection initiates from on-prem to known trusted addresses, and we'd want to lock that down a little bit to known Azure services, things like that nature. But usually this pattern of outbound HTTPS is less of a problem than inbound anything, HTTP in particular, or TCP even worse. So
yeah, no, I know the streaming is outbound. I was actually thinking more about the kind of the DevOps cycle, because you made some good points about ability to manage the operations a bit better. And so I'm thinking, if you're pushing this code, or this container executable, whatever the service, to a bunch of devices, that is an inbound.
Nope. That's a really good point. So what happens is the connections are all initiated from IoT Edge out to IoT Hub, all of them. So and then it holds, and it periodically polls to see any new instructions, like, for example, go and get a new version of this stuff. If it gets that request, if it's told to go and get some new stuff, it makes an outbound HTTPS connection to Azure Container Registry, once again, to go and fetch that container and bring it down. It's all initiated from on-prem, it's all HTTPS, and it's all outbound to Azure.
Gotcha. That's
Our
cool.
cybersecurity folks go, okay, that's generally speaking. so usually that passes muster.
Yeah, no, that's cool. I like the administration.
Yeah, really good questions. Really good questions, because that's real world. Those are real world issues and concerns. And that's obviously the intent of my little demo here is to match real world, solve real world problems. Okay, fine. So let's see. So this is my code. There's not much to show on the IoT Edge device itself. You can shell into it. There's not much to see, frankly. So I won't demo it. It just sort of does its thing. Set of command line tools. Push this code. I think maybe it might be picture time. So let's see what this solution might look like. Let's try and get this up. The whole thing. I'll show the entire thing to make it easy to understand what we're going to do here, because we've left sort of the creative bit. There was a lot of ways of solving this on-prem, if you will, valid ways, right? And I'm trying to show, but now we're getting into Azure. What I just showed you was how I get the data into a service in Azure. And in fact, I get it into IoT Hub. In fact, a service as part of IoT Hub called Event Hub. So it's native service in Azure included in IoT Hub. And so let's just walk through what we've got so far, and then I'll show you the rest of it, and people can and diagram some of the things we just talked about. So okay, aircraft goes overhead, little antenna thing spots it irrespective of the internet. Remember, I have a little Raspberry Pi 3 running this is my little black box running. Oops, I realized my fat head is in the way again. Sorry. Little Raspberry Pi running over here. This is the black box on-prem in my attic. And then we have the IoT Edge device, which is I chose a Raspberry Pi 4. I showed you a stack of them that are not my ones. I can't show you my real one because it's running. It's in my on-prem colo, right? Connected to my network. It's plugged in upstairs somewhere. And so just in the network, so where it can see my my Pi 3 right here. Wait for the Pi 4 because I know it was cool and I wasn't sure how much oomph I'd have. And I wanted the ability to do other things. I toyed with the idea of running a SQL server, the full-blown Microsoft SQL server as a container on my IoT Edge. Toyed with the idea of writing data to that as maybe some kind of backup or cold storage. My device there has enough oomph to do that. So I could have, but I resisted the desire to do too much on-prem, preferring instead just to egress it, mostly, with only a minimal amount of cleaning for the reasons I was showing. A, lazy, and B, give myself the opportunity to change my mind later with the data that comes in based upon what I learned from it. All right, so as you saw in my code right there, it sends it up to IoT Hub. So 1, aircraft spotted, updates every second. 2, that code that I wrote and is deployed. It's actually deployed via a DevOps process I sort of talked about. There's no point in showing it. The code is deployed, built and deployed to an Azure container registry, sort of indicated by my diagram right here. And the IoT Edge pulls that and launches my container automatically. My thing reboots, automatically launches my container. Don't have to do anything. Again, that's more things that if I didn't have IoT Edge, I'd have to solve for, right? My Kubernetes cluster, for example, power cut, I'd have to relaunch all my containers on that thing and get it all set up again, right? So that means UPS supplies and all kinds of traditional on-prem data center things to allow for the fact that bad things can happen and we have to put infrastructure in place to handle it. Don't want any of that. So I want IoT Edge to basically do all the work for me. And so it does. I don't have to worry about internet, don't have to worry about power, don't have to worry about it rebooting for any apparent reason. Just it reboots, it gets my container, it relaunches it, it just kicks off, does its thing, that's it. Which suits the lazy in me, right? So, okay. And then sends data number 3 to my IoT hub right there. I mentioned via HTTPS. So the little dotted lines indicate the data flow. So it sends 1 message for each flight, in fact. So it breaks up that page into a whole set of flights, however many flights that is, makes a message of each one, each payload, each individual flight, and whatever we know about it, that row of data. And so each refresh of the page might contain 5, 10, however many flights, however many aircraft were actually visible to my little black box here at that particular time. 1 message per flight at the same time. So it sends them all just continuously. So we got quite a lot of messages, quite a lot. So again, that's one of the aspects that we were looking to deal with here. I got some performance concerns. IoT Edge just deals with it, so we don't have to care. All right, IoT Hub is the ingestion mechanism for getting all that telemetry that you just saw in our code. What then? Well, let's talk about Event Hub just briefly. This is a service specifically for solving this kind of problem. Huge amounts of data, often from IoT devices such as this one, that scales right out, and you can just ingest millions and millions and millions of such messages every second, all the time, to be a same Event Hub. So if in this pattern that we have here, I had a lot of these little Raspberry Pi devices dotted all around the place, however many I wanted, and corresponding IoT Edge for each one, of course, the exact same pattern. I could use the exact same code from the same container registry to deploy to the same Event Hub from every single one. And that would not be a problem. If I chose to differentiate based upon the location, I could, if I wished to, if I needed to for business reasons. Yeah, I could add that data in there like I added the timestamp. Yeah, I could do that to every single message and send it up to the same Event Hub and then figure out what to do with it at the Azure end. Yes.
Bharat, I have a question.
Yeah.
Why are you not using the IoT Hub instead of Event Hub?
So great question. I am using IoT Hub, which includes an Event Hub. Yes, it's not really shown on my diagram right here because I couldn't find a great icon. But yes, I am using the IoT Hub service as the endpoint for my IoT Edge. I have to, in fact, because my IoT Edge has to be registered with an IoT Hub.
Got it.
So I am. Thank you. That's a good call out, though. It's not shown on my diagram anywhere. I should draw a box around here, call it IoT Hub, and within that service is an Event Hub component. That's the messaging piece used to actually send the data. Yeah, thank you for mentioning that.
No worries.
Yeah, so yeah, IoT Hub is my mechanism for managing my IoT Edge. IoT Hub allows me, and I'll show it in a bit. I'll show you my IoT Hub and my IoT Edge device that I can see remotely from Azure. But just wanted to describe the pattern first and then walk everyone through the implementation of how it actually works. So, and then as part of, like I was saying, part of IoT Hub, I get this messaging service, IoT Hub, I get event hubs as part of it for ingressing telemetry, because of course that's the most common use case for IoT devices is ingressing lots of telemetry. So Event Hub is the service for that. Any other questions while I just take a water break?
Looking at this diagram, I see you have a Power BI connected directly to Streaming Analytics job.
Yes.
How does that work?
Great question. Yeah, it's a very simple answer to that.
Pretty well, actually.
That wasn't the answer I was going to give. The answer I was going to give was magic.
Magic.
Yeah, no, just horsing around. Yeah, I'll show you that. I'll show you how that works. Because great question. But let me get there. Walking through my little picture. It'd be great if I did this in present mode. Oh, great. That's not great, is it? All right. So, okay. So we have event hubs right here. And then, yes. So what does most of the processing work is another service outside now of IoT Hub called Stream Analytics. Now, I mentioned can run this service, Stream Analytics, actually on my IoT Hub. So this could, if I wish to, run on-prem as well. Same service, in fact, if I have enough horsepower on my little box here, which, as it turns out, the Pi 4 actually has enough horsepower for a little bit of Stream Analytics. So I could do some real-time processing upon messages. And the way it works is I've got my little container running my code. You can see the same code right there. I could have a Stream Analytics also running on the same IoT Hub that listens to the messages coming from that before they are sent off to Event Hub. So look like a little on-prem pipeline, if you will. Yeah, I can do analytics and do processing and stuff like that on that streaming data. And you'll see the kinds of things we can do with it in my implementation in Azure here a little bit. So chose not to do that. Just know that that's an optimization I could make if I wished. So Stream Analytics is then, as you can see, the one and only destination for all of my telemetry right here. And then I have classic hot and cold path, right? Now, the business use case that I was trying to describe, we're going for here is want to know real time when this cone I described, imaginary cone around my desk chair right here in on-prem, the GPS coordinates of which I got from my phone. So that's a known location, if you will. When one of those aircraft that report GPS coordinates, because as we saw earlier, not all of them do, when one of those report the GPS coordinates and they're within 100 or an arbitrary amount, a business amount, I've gone with 100 meters actually, just for funsies. 100 meters of my chair in a cone that is of infinite height, then we want to know. So all this data first comes to Stream Analytics, and then I dump it out into a few different places. One of those, this one is actually, I've not labeled it, Cloudy IoT Data. It's actually an Azure storage table. So why have I put it there? Because it's cheap. So this is sort of a low cost object storage, if you will. Don't actually do anything with it after that. I just felt like storing it there because it's cheap. So if I, and again, pretty much relatively minimal processed in there, just throwing it all in there. And I'm using the table storage because, it passes it out, got columns and such like in there. It's a bit, I could maybe have, if I wanted to put in blob storage, but I chose table storage because it's a little more native, right? Azure storage, native table storage, not blob storage. Now, could have used CosmosDB, which also supports the table storage API. Don't need that, cost too much, when in fact, I'm actually using it over here, as you can see. So we'll get to that in a bit. So yeah, that's my cheap storage for all my object data. Terence, any questions? Or I'm not sure if you're about to comment or not, or if you're just off mic unintentionally.
Oh, I'm just off mic unintentionally.
It's all good. No problem at all. Okay. I wanted to give you a moment to jump in if you were waiting for a good moment. No worries. So okay. And then we have, yes, as someone spotted, also egressing it straight out to Power BI. That is because we have a connector for Power BI specifically for stream analytics. So this isn't, if you're those of you familiar with Power BI, and I'm not a big Power BI expert, just going to be honest with everyone about that. But when you use Power BI, those of you have there's various connectors that fetch data, right? You connect them and pull from various sources, SQL Server, for example, being a common one. And this is not one of those, right? You don't, this, as you can see from the arrow, we are sending to Power BI. Power BI is not fetching from my stream analytics job. And that is the key difference. That's why if you've ever used Power BI and you're trying to find the stream analytics input connection to read from that, yeah, there isn't one. It's the other way around. What happens is at a high level, stream analytics it sends out to Power BI and you configure it with your Power BI account. So it just appears as a data set in your Power BI dashboard, continuously updated, and then build your report from that. It's just sort of magically there. If you will, and you just connect your report to that magically populated data set, refresh away, there you go. Any questions on that? I know that was a point of curiosity.
Adam, I have a question.
Yep.
What is the partition key and the row key you choose to store that entity in the Azure table storage?
Oh, yeah, because that's pretty important. I forget. We'll go and look at that in a minute, and that will remind me why I chose those things, because those are important decisions. I think one of the key things that we cared about was one of the keys that I decided was important was the flight. And so that is one of the keys. And because of the way the data appears, and the way we might, so that's I think the partition, and then I think the time is the row key. So I think I was grouping them by those two. But you know what, we'll go look and see, because that was an important decision. I just can't remember. We have the same important decision to make actually with Cosmos. So we're going to go look at that too, because that impacts our performance. And we'll drill some more into that. But yeah, good questions, Mike. These things are important.
I have the Power BI question. I understand that you just said that you're sending the data to the Power BI.
Yep.
Do you send the historical? Does the Power BI store all the historical data? So for aggregated live analytics, or you're just sending the data by a specific window?
A specific window of data being dumped on there, so I can and
Right,
Power BI does some aggregation as well. But honestly, candidly, I'm getting to the hazy edge of what I know of Power BI at this point.
If you want to do a historical data and do aggregation, also have a live stream,
that's not going to work, right?
It has to be on top of any like a Synopsys or CosmosDB or something. That's why I was wondering, now is they're saying just sending that a window like 10 seconds or minutes of data to Power BI.
Indeed. So, okay, yes, let's clarify that. if I wanted to see the historical data over time, then I want to point my Power BI at my historical data store, perhaps this one in my SQL here or Cosmos, something like that, where everything is, and let it sum and slice and dice and do all of those things for me. If I want to see it in real time, I want to see it right now, then obviously reading from historical is not going to be not going to cut it, right? So that's where I use this Power BI in real time, sent just the things that I care about in real time. So I could, if I wanted to see historical, add another little arrow right there to my cold data store, if you will, in order to see both real-time views in Power BI and whatever historical reports, slicing and dicing I want to see.
Yeah, but on the Power BI side, how do you refresh the views to be able to see, say, if your window is 30 seconds, and do you schedule Power BI to refresh the view 30 seconds or every 10 seconds? How do you keep the real-time data coming into the Power BI and the view of Power BI refreshes on its own?
Good question. So the data is sent to Power BI all the time automatically. I mean, it's just always sent there. So it's actually always up to date. And when I have to manually refresh the Power BI report in order to pull from that real-time data set in order to see the latest. But the data is already there, if you will, in the sent to Power BI. It's just pulling it out from the real-time data set.
Assuming that you chose streaming as the specific type of streaming data set, that data is kept in for about a buffer of about an hour.
Okay.
And so, yeah, as you continuously send to it, there are some limits on how quickly you can send into that. But Power BI itself, for a streaming data set, will keep that for an hour. And then if you're wanting to look at it in tighter slices than that, then that's all going to be on the visual side, where you're going to filter down most recent to how far back in the history you want to go. But you keep about an hour.
1 hour. Okay. Thank you, Sergio.
Yeah, the data streaming is pretty mature on whatever platform, Azure or AWS. To get the real-time visualization, the real challenge is refreshing the view on the visualization side.
Okay. So I think what Sergio is showing, we have right now back to an hour's worth of real-time data we can see, and we can just hit refresh on that thing, or maybe there's a way to set it to automatically pop up or change the visualization. It is the real-time data in that regard. Anyway, all right, we can look at it. I do have a fairly primitive Power BI report that, as a result of this, we can look at. I'm not a big expert on Power BI, just again to be candid. So maybe might have to explore some of these. Get back to you on some of those questions. We'll see. Or maybe I'll just ask Sergio. All right. So okay, let me carry on with my little diagram right here. And then we'll show some components, and you can ask any questions that you might have, or explore it anymore, other ways of doing it, or whatever we like. So Stream Analytics comes in, sends some of it to Power BI, all of it, well, all of it, I should say, to Power BI, all of it to my table storage, cheap table storage in my storage account right here. And then also sends it to CosmosDB, because we've got some fun stuff we want to perhaps do with historical data right there. I'm not going to use this for real time. There are some real time aspects to this that we'll explore. We'll come to that in just a second, just for funsies, a couple of functions that I'll call out in just a moment. But for our use case, right, real time, wanting to know aircraft, cone, etc., don't need Cosmos for that. Stream Analytics, in fact, does what we need, as it turns out, has that ability native to it to basically do the processing that we need, in fact. And it actually will stream the data and find us, given a particular lat and longitude. It has the ability to process geometric lat long data and calculate distances for us natively. We'll see that in a little bit. And if those and filter those out, geospatial. Thank you, Brad. Process geospatial data for us and can do the mathematics and distances for us and tell us, actually, all right, this aircraft right now that came in this nanosecond is within that threshold, and it will send just those results to another service in order to enable as part of our hot path. So I've sort of tried to draw the line a little bit differently. This is only those aircraft out of the thousands that are coming in, those that conform to our particular requirements of in fact GPS coordinates, right? Drops a message into service bus, just one each time an aircraft fits the criteria, upon which a logic app is simply listening to that service bus for those messages, which of course will be at, very generally speaking, pretty low volume, because we've got a very, doesn't happen a lot, right? Varies, of course, and that's I had this much further. I started out with 1 kilometer, 1,000 meters, and I got a lot of messages. Turns out a lot of planes fly within 1 kilometer of my desk overhead. 33,000 feet quite often, but nonetheless quite a lot, as it turns out. Too many actually, so I reduced the distance, and now yeah, so 100 meters seems to be, I get a couple a day, 2 or 3 a day. So and then my logic app is simply listening to every message on my service bus right there, calls Twilio, which is an external service for messaging that I happen to have an account with for this purpose, which then, so logic apps have an adapter for Twilio native to them, making life easy, because again, lazy, don't want to write any code. This is a codeless solution, so I'll show it. No code required in order to build this piece right here. So this hot path right here, I was mentioning earlier, lazy, don't want to write too much code. Could have written a lot more code on the bottom here. After that code here, no code required, no code required, and then I get an SMS message on my phone with the flight number that it flew overhead in almost immediately. So this happens within less than a second from actually when it's written to my IoT. So when this plane is spotted, sends the telemetry to my Raspberry Pi, update every second. Within after that has happened, within a couple of seconds, when we have a hit, it hits my phone. So that works pretty well. I'll any questions on that point before I just talk a little bit about this piece and also mention Twilio a little bit. Any comments or observations?
No questions, Adam. I was just going to add for Don's awareness, when you use a streaming data set, if you're creating a visual based on the data set, it updates on its own, so you don't have to hit refresh. That's the point of the streaming data set. Don't want to turn this into a Power BI discussion, just FYI.
Yeah. I didn't know that. That's good. Good to know. Thank you, Terrence. I learned. Or maybe I knew that and forgot. That's also possible.
And I guess for this particular use case, the volume is low and we don't really have enterprise class, first in, first out kind of thing. That service bus can be probably replaced by like cheaper thing like Azure storage, things like that. Azure Storage Queue, for example.
So that will not cut it in terms of performance right there, right? So we want performance. We might scale this out, right? And so yes, Azure Storage Queue. So I've got a storage account right here. Would be real cheap, and I could from here directly call Azure Storage Queue, put a message in there, but then what do I do with it? I could have my logic app listen to every single message, but then my logic app would then have to do the processing, because remember, all the messages being sent from my IoT hub, it's all of them, including ones and wherever they are. I'm not doing any processing. Now, I mentioned I could do it using Stream Analytics on my device. I chose not to, but I have to do the analysis somewhere and do the math of, is this particular GPS coordinates within that 100 meters somewhere? I can do it in different places. And actually, I will share at this point that I did initially start that. I did do it actually in a logic app initially when I was first doing it. I still used event hubs as my ingress service, because that's native to IoT Hub, right? It's just I used IoT Hub and IoT Edge, and event hubs comes with it. It's native. So if I'm going to use IoT Edge, I get IoT Hub anyway. I have to have one to manage my IoT Edge. So it's not that it's cheaper. Honestly, not a very expensive service at low volumes anyway. It's not an expensive solution. But I'll tell you what was an expensive solution, using that logic app. Oh my goodness. So yeah, that was a pretty interesting an interesting experiment, a little learning for me when building this solution. I first solved it not with Stream Analytics, so I thought that would be incredibly expensive. Didn't look at it. Just I know logic apps, and I started with that. Right, I started with that, and I built a logic app that listened directly to Event Hub because there is a native connector, and skipped this part right here, and actually just did the processing in the logic app. So it just, and again, no code, wasn't particularly difficult to write the logic app. Every message, just it fires each time for every message. And so for each message, I know the schema, just parsed it out, looked for what I cared about, did the math right there in the logic app, wasn't too difficult, and then responded accordingly. Sent it to actually Cosmos was the storage where I wanted to put it. Although actually initially, before I got to Cosmos, I was just writing it straight to cheap my table storage. I just had my logic app write it to table storage, and I didn't have Cosmos at that point, but I could. Now that I've got Cosmos, just write it to Cosmos instead, and then also the Twilio part right there. So, and as you can probably sense, there are a lot of messages sent to my Event Hub, which okay, who cares? It's Azure's problem to scale this thing out, right? And let me tell you, it worked perfectly. Not a glitch at all. Just I got one execution of my one logic app that was designed for each message, worked like a charm. But honestly, I think I might have hit $2,000 in a month for logic app executions, and that's when I thought I might need to re-engineer my solution, because there were billions you get charged per step in a logic app, and I was hitting many billions of steps in my logic app. So that actually turned out to be not a cost-effective solution. It did work. It worked perfectly, wasn't too difficult to do, but was not the right solution from a cost aspect. Did also try and run my logic app. You can run them for a standard logic app and put it on an app service plan. That's also another option you can do with logic apps. Turns out that it needed a pretty big app service plan. Turns out actually needed kind of a lot of horsepower, is actually what I found out. Not visible when you're just using a straightforward logic app and it just executes without you having to care about it. Turns out when you see that horsepower, there was actually quite a lot of it. It was not any cheaper because I needed kind of a lot of app service plan to run it. So that's when I realized, okay, that needs quite a lot of horsepower. Not a good choice. So abandoned that pattern, and that's where I ended up with the service bus.
Oh, sorry, I have to clarify. I meant the Azure Storage Queue to replace that service bus component, which is post-processing by Stream Analytics.
Thing.
Yes, yes.
Yeah. Can't do that because Stream Analytics only has a set of only very high performance eventing services, and storage queues is not sufficiently high performance enough. There's no connector for it in Stream Analytics. Can't send from Stream Analytics to storage queues. Tables, yes. Storage queues, no. So can, however, send it to Service Bus, which is an enterprise messaging service, high volume, etc. Hence, that's the way to go. And that's honestly what you'd want. I understand that, yeah, of course, you want to be cheap. I'm cheap. Being cheap is good, as you found out when I spend too much on my logic app. Not a good idea. I'm cheap. No. So, yeah, we want to be a cost-effective solution here. It turns out, actually, Service Bus, pretty cost-effective if, it's not a very expensive solution. Most expensive component of this pattern is actually Cosmos. And even that, not that bad, honestly, because I got the free account with my Cosmos on this one. So anyway, doesn't cost very much to run this whole thing. Did when I used Logic App, not so much now, because this, of course, only runs whenever there is a message, because Stream Analytics is cleaning the data. So yeah, very, 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 very cheap at low volumes. All right, any other comments or feedback before? Yeah, Cosmos is great. Yeah, do you remember yeah, we had a good debate on that one in a previous presentation. I think we were talking about SQL Server, traditional SQL Server and RDBMSs, and in fact, it might have been a presentation on Cosmos. Yes, Mike's been around a long time. All right. So this Cosmos really is a bit of a cold store as well in many regards. We want this for handy dandy reporting, really. So, and we want to be able to do some math on this thing. So what I want to know, because it turns out Cosmos actually does some handy dandy geospatial stuff to it. It understands geospatial, and that's cool. So we want to use that. Storage right over here does not, so that's not cool. So we don't like that. So we want to use the cool storage geospatial features of CosmosDB in order to keep a record of all of the closest flights and how close they got, right? So that is fun and interesting, and we want to know that. How close were these flights? Not just, hey, one is within range. How close did they get? And we want to know for every single flight, the closest it came, just because that's fun and interesting. We want to know. And now, the way in which we get to that problem, we could, and I did initially, just dump, as you can see, all the data is dumped into Cosmos. One problem with the raw data is that it's not actually in the right format for the geospatial that Cosmos it expects. As you saw from our JSON, it was just lat colon some value long colon some value. Cosmos just thinks that's a string and a number, and yay, great. It doesn't care. It doesn't know anything. There's no geospatial special about that. We have to have that in a particular format, which I'll show. But it needs to be changed. I need to change the data a little bit, and I'll show that. All right, how do we change the data? The easiest way to do that is actually to use what's called a feed. There is a feed off of the CosmosDB change feed that whenever anything is written to this CosmosDB, I can hook stuff to it that responds, hey. And what I'm hooking in this example, so what I'm trying to show here, my Stream Analytics sends it to Cosmos over here, which dumps it into a CosmosDB table, creatively named flights, one entry, one document, if you will, JSON file per flight, just dumps it in. There you go. And basically Stream Analytics is done at that point with dumping stuff into Cosmos. However, like I mentioned, we cannot use the fancy schmancy geospatial features of Cosmos to, for example, tell us the nearest, how close the individual flight got, or any of those things over time, or any fun things that we want to know. It can't tell us that. So we hook a function to this change feed, which basically fires, it executes every single time any one document is written in there, which of course is going to be by Stream Analytics. So every time this fires, we get that document and we get the opportunity to do whatever we want. What I do is I change it, correct the data, in fact, clean it up a little. I change the lat.long, just basically, paired documents, to the format that Cosmos expects in order that it recognize it as a geospatial object, actually. I change that data, remove the useless lat.long values and put them in the right value that Cosmos expects, and I write it back, which actually triggers the change feed a second time, at which point my function fires again, this time with the document that has been corrected. And so I can make sure, okay, has this document been fixed? So I have to check that every time. I share it in my code if I'm interested, and then I do nothing because that'll be the second time we've seen that document in our function. And that's how we correct and clean the data that's dropped into our CosmosDB. So we tied it up. And then as well as, I think I've drawn this, not okay, this is not quite right. I have another function. Yeah, this one doesn't actually write to this close flights. table. I have another close flights table. I need to correct this. This is actually over here, and this one is from this one. Let's just okay, correct my diagram right here. Okay, so we have another CosmosDB table, and we have another CosmosDB table. I'll explain why. This one contains what the business data we want to know. What we want to know is what are all the flights individually and how close did they get. Now, this information, as you hopefully understand from what's dumped into our flights, it's actually available in this table. We can just do a SQL query and pull that up. And Cosmos, let me tell you, it will absolutely, it'll pull that up. We can know that it is a knowable thing. Not a problem. Can anyone guess what the problem is with doing it that way? Sleep.
Just the partition key thing.
That is important. It's important. The partition key and choosing it is important. Yeah, and we actually want a slightly different partition key. That is not the problem with just getting the information out of this flights, because the data's there. Like I say, we can craft a SQL query and we can iterate through this in order, every single flight. Because remember, what we're storing in here is every time any flight is seen, every second. It's all in there every time. And what we care about is how close did it get each one. So a unique list of flights and how close each one get. So not a very long list.
So would it cost a lot in the function cloud cost to do that lookup every time? Is that why you separated them out between all flights and close flights?
Good question. Good question. And you have hit upon the problem. Yeah, it's the cost, but not in terms of the function costs. In fact, this does not cost a whole lot. This is not a high cost operation to just clean this data each time and put it back. That's okay. We use a capability of Cosmos called Patch, recently released feature to make only the changes to the data that we need. Prior to that, it would be replacing the entire document, which is a much more expensive operation. Now, the thing to understand about the way CosmosDB pricing works and its scaling is that you're charged for an arbitrary item of performance, a DTU. God, man, I'm getting tired. This is a DTU. And so you pick how many DTUs you want for your Azure CosmosDB table. You can have it auto scale, and you pay for how many of those gets used. And they represent, basically memory, storage, and compute. Essentially, is what they equate to. And Cosmos will tell you, because it bills you on how many DTUs any given query actually consumes. Now, because unlike traditional RDBMS, any given query, you're limited by the horsepower of whatever you're running that RDBMS on, Oracle or SQL. So how big is that box? Because that's the limit what your query can do. What is the IOPS of that? Traditional infrastructure limitations. That's the way of it, right? Cosmos, it extracts all of that. It's not a problem. It will do what you need. However, it'll calculate whatever the resources it used, and it can use a lot of resources or hardly any, and you get billed for those resources. So the long reason that I separated it out into a separate table is because making the query against flights very often turns out to be a pretty expensive query. It doesn't take very long, but it did use quite a lot of DTUs, and it maxed it out, and it would have been expensive to do that very often. So the solution to getting this data, I've called it close flights, which is basically how close every flight we've ever seen, how close did it get, and that's it, is a durable function here. So basically a long-running function, because even though Cosmos, it scales out, turns out we have, and we'll look in a minute, we have millions and millions and millions and millions of records in here now. And when iterating through every single one of those and doing the mathematics, the geospatial mathematics to see how close it got for every single record, it exceeds the maximum duration of a standard function right here of 10 minutes, close as it can go. Question, Andrew. You're on mute, sir.
Thanks for that.
No worries.
Sorry, I did get pulled away briefly due to a operational issue, so I'm hoping I'm not misunderstanding some of this here.
all good.
A couple of things, and they are both in a sense related to what you're talking about. So the first thing is proximity is based on proximity to where you are, and essentially that's a piece of configuration information. I'm not sure whether that is coming through in the feed from your device, or in other words, you sidestep the need for that configuration. But if not, I was just, as a very small question, I was just wondering how you were handling that configuration thing in terms of maybe needing it in multiple places. And the other one of thinking of the geospatial calculation, i.e. distance to, as being a small compute job. Based on what you're telling me right now, that isn't this happening in several places? So, for instance, isn't it happening in your stream analytics job? And if so, can't you persist the distance across to Azure CosmosDB and remove the compute burden from there?
Two really good questions. I'll answer them in the order you asked them. So, yes, I've effectively hard-coded the origin location, if you will, in the places that care about it, which would be my stream analytics job, as you point out, and my function hard-coded in there. If I were to scale this out and have multiple locations, then I would have the IoT Edge write an additional, like you saw in my code, it wrote the current date because I don't have the actual current date in my data. I have it in a format that I decided I didn't want, which was Unix, and I would add the location of that IoT device, which would be a parameter specific to that individual device, or I'd have a way of looking it up or something, but I'd probably just write it to have the device write its location, and then to every single message that goes through, and then have it as a value in every single message added to the data. That's how I'd do the scale problem rather than the current hard-coded solution that I have. And yes, I probably could use Stream Analytics to do that calculation and then write it from here to close flights. I probably could do that. Yeah.
Yeah, I think my question on that one was more, aren't you already doing that? You intimated, I thought, that you were doing some of that in order to filter down the messages that go to the nearby aircraft processor.
Yeah. So I'm doing some math, yes, using geospatial, correct, in order to send them over to here. This output right here is just everything, but it sends it to this table. I think you're right in that I could also do this, do some send to this table.
Yeah, my basic thing was that in the stream analytics job, you essentially have to calculate the distance to send to the nearby aircraft processor.
Well,
and then if you add that in,
So the stream analytics jobs works off of a tumbling window that is about 3 minutes. So I have a 3-minute window over which I trigger this right here. Okay. Here it's all time. So I actually want to do the math in all time. How close did any flight ever get? So I think actually I can't do it in stream analytics given that particular requirement. So the need here is I need historical data. How close did every flight get ever? How close was it? The stream analytics job will never know. It only looks at a tumbling window of the last 3 minutes and triggers it then, and that's it. So
okay, sorry to pick at this a bit more.
No,
and again, I apologize because I'm misunderstanding. See,
that's all right.
So possibly I've got a misconception here. So all of your messages are flowing into the streams analytics job.
Yes.
It is triaging some of them to go to the nearby aircraft processor.
It's sending them all to this here. Yes, on a tumbling window, it looks to see if it falls within this 100-meter range. If it does, it sends it. If it doesn't, it doesn't send it.
So to figure out if it's in the 100-meter range, it has to calculate the distance.
It does. Correct.
So at that point, you know the distance for every single message. And my question was simply, can't you persist that across as you're messaging to Azure CosmosDB? You've already done the distance calculation.
I could add that when I send this feed as a distance. Yeah, you're right. I could. I don't. That's actually a good suggestion. I could add that piece of data to this. I think I could do that. Yeah, it's a good idea. good idea. I don't know. And so I calculate it using my batch processor right here. Good suggestion. Excellent.
Well, I think another thought that comes to mind is,
Yeah.
what if this were, you were moving, so you're in a vehicle, then you should be able, with the analytics streaming AI, triangulate what your position is, and then know based on where you are triangulated from the other aircraft when something's over within the radius for triggering an alarm.
Yeah, I think that was similar to the answer I gave when Andrew was asking how I'd, if I have many of these, if I have lots and lots of IoT edge devices here, I would have each one send its actual location.
I don't know
Let's
why
say
I filtered
if
that
it
out.
was moving, yeah, which is a great idea. I mean, could it do? Yeah, I don't see why not. Yeah, let's say it's moving. Put it in a car. Sure. I love it. Then the same pattern would still hold as long as we had a mechanism for determining the current location by GPS, some other sensor that was connected to my IoT edge, which is a common that is a common pattern. Actually use that in the real world in the oil field. Sensors on the oil field are connected. We have customers that have connected to the IoT edge, and that is the ingested telemetry that can vary from those sensors, and then IoT edge then sends it on. GPS could be such an example with an appropriate sensor and the current location. Add it to every single message, and then yes, Stream Analytics, instead of the hard-coded value I have right now, would send the real-time and triangulate. Yeah. All right.
It was one of the function's job to correct the kind of format of the data. You mentioned that CosmosDB
this one
expects. Okay, is that a use case where you should maybe cleanse that data before you even send it out locally? Because I imagine that's a very low CPU, like low in overhead job, right? Just to formulate that data.
I could. Yes, I could do that on the IoT edge device itself. I could do that here. Yep. So I could run a function, in fact, on my IoT edge device in a container. That is something I could do. Yep. Good idea. I wouldn't be able to use the Cosmos, so yeah. But yeah, great suggestion. I could do that if my IoT device had the horsepower, which it does. So yep, valid suggestion. An improvement, actually.
Well, from that perspective, you could even push the compute burden of the distance calculation out to the edge as well. I mean, as you said before, there's a bit of a tension between where you want to do certain kinds of transformations. Some you might have a preference for central, more from a management perspective, but then there's something pushing in the opposite direction in terms of cost, where pushing some compute to the edge reduces costs. So
indeed, and that's where I landed. I landed on basically doing most of the just using IoT edge to just send it, and that's all it does. Yeah, but those suggestions are perfectly valid. That's right. That is the tension you just called out. But neither are wrong. Just depends. All right. Okay. Any other questions or observations? So we can just go and have a quick look at some of this stuff in the Azure portal to see how it is. Ask any questions. Been here a while. We're only supposed to go till 8, but we've had some really good questions and discussion, and I've rambled a lot. So,
what was the total monthly cost of the final prototype?
Good question. I'll see if I might tell. I mean, remind me, and we'll take a look at cost management on my subscription and see how much.
I'll put it in the chat.
Yeah. Okay. All right. Fine. No more questions. Then let's look.
I had one. So if you did find an improvement like that needed to happen on the IoT edge device, and that device is inaccessible, like in your attic, how would you push out an update?
I would use a DevOps tool chain, which so I would use code right here. So I'd make the changes to my code, which does not depend on me being on-prem, right? I could be elsewhere, and build and deploy and push this code to my Azure container registry, and then I would configure IoT Hub, where my IoT Edge is connected, and tell it, go get the new version of my stuff, and it would pull the new version of the code from my container registry without me being on-prem or talking to it at all.
Okay, and so your IoT Edge is always polling that hub.
Yep, it's
for
connected.
jobs to do. Okay.
Stuff to do. Yep. It has other things. I can send it messages as well. I can tell it to do things. It's actually looking for messages that I can send it. I can update. There's a whole bunch of features that I haven't used, but it can do. Yep, that's the code being but one of them.
I had an earlier question in chat that you probably missed, that if you mentioned the resiliency about local network. If the internet goes down on-prem and those messages are queued, and when the internet comes back, the IoT Edge device will automatically restore those messages back to the cloud without any user intervention, right? Okay.
Right. Yep.
And you can store, like, is limited to the storage of the actual device.
Correct. Yes. Okay, let's see things to look at. Oh, actually, I was going to show some code first, just real quick. Let's look at. So I showed the code that's running on my IoT Edge, which is this right here. It's going to show that's I creatively called it data fetcher. That code runs on my IoT Edge, and then the same GitHub project. I also have the code for my Azure functions. And I have a GitHub pipeline that pulls from the appropriate source code. So I'm able to mix and match these, even though completely different destinations and build properties and everything. So don't let the fact that these are in the same juxtaposed like this be confusing. These are the functions that run in Azure, could run on my IoT Edge, as highlighted, and do some work locally, but they actually run in those functions. And so this one is this is the one that this is the one that fires every time it listens to the change feed of my CosmosDB. So I use the CosmosDB SDK, and I'm getting all kinds of squigglies that I haven't actually figured out why that is. The code does compile and push. I'm not sure why code is throwing me squigglies. I haven't figured that out. But anyway, it's not erroneous as code seems to suggest. So in any event, we get a CosmosDB client like so. And just for funsies, we use, you might have seen on my diagram there briefly, we get a telemetry client, which is application insights, part of Azure Monitor, because we're able, maybe we want to see some additional custom reporting on what's going on right here. Why is Razor choosing to update right now? And so I send some additional custom telemetry to application insights in order, as well as general performance statistics and errors and things like that. Also some custom telemetry just for funsies in case I wanted to use Azure Monitor to see it and alert it in preference or in addition to Power BI. So that's why that is there as an option little piece of fun. We can send custom telemetry from our code in using application insights.
Is there a reason you had to inject that telemetry client here instead of using the integrated Azure function application insights where you just turn one click in the portal?
Yeah, the one that's integrated into the portal will pull the default telemetry from Azure Functions, and is great. But if you want to do something a little more custom, which is what I'm looking to do in my function right here, which I think we can jump down to that. There it is. If I want to do get a particular set, a particular custom metric in application insights that's got nothing to do with CPU or memory or any infrastructure stuff, something specific. So I'm doing a particular metric, which I think which is basically the name of the metric is actually the flight number. So I'm going to have one metric per flight in my application insights, and I'm going to add a counter to it, tracker value. So update the value of this flight for 1. So in my application insights, I'm going to have custom metrics named for the flight and how many times I've seen it. I can only do this by getting this telemetry client. Answer your question? Mike?
Yes.
Yeah.
Yes. Yeah, that's great. Thanks.
Yeah. Again, just some funsy stuff we can do with application insights, in addition to the usual, like so. This is the usual right here. This log is the logger we get out of the box with functions, right? Log error, whatever we've got, just yeah. Or even if we don't do this, right, and just my function craps out, the default application insights will catch those exceptions and drop them in application insights. So this is
when you do this injection, does the portal version get affected? Do you disable that one? Do you run them simultaneously?
It's the same. It's the same. We're just using this allows us to use the specific APIs of application insights to do this custom get metric, whereas this is more generic. But
I mean, like if you use this one but disable the one in the portal, do you still get the other standard stuff, like you said, the exceptions, CPUs, that kind of stuff?
Yes, you still get the same telemetry. So when you enable it in the portal, as long as you're using the same key, it's just going to track the infrastructure telemetry by default to application insights, and then this is basically going to add additional telemetry sent to the same application insights instance identified by that key with additional stuff, if you will. So it doesn't override or change it. This simply adds more stuff.
Gotcha. It's not going to cause any duplication either, right?
Right. It's not duplicating it.
Thanks.
Yeah. So yeah, the purpose of that was only showing the power of application insights for viewing and monitoring whatever we're trying to do with our stuff, right? And the reports and application insights can be used to show business reports as well. We have use cases for that. Right. Anyway, so we do some converting into some static objects right here. We set some. This line is because our function might get called twice. It might get called twice because we fix the data and then save it, and then the change field will trigger a second time because we have actually patched it, and then we get called a second time. This here traps that second time, or also if our data is just junk and we don't care, then this allows for some errors and mistakes sometimes that might. I had some lousy data a couple of times early on. This means my function can just ignore that data if that comes in. So just using the SDKs for Cosmos to get the database. And then I mentioned we're using a feature of Cosmos to patch the data, not update it. Relatively new capability. So we've got a set of patch operations right here. We create one, and then we actually do a set of there's 4 different patch operations. We add this location object of a type point. So this is basically creating the JSON in the way that Cosmos expects. There's a standard for geometry data that it expects, and we're just going to put the data in that standard. And then because we've done that, we add that into a field called location. That's our new geometry data, and then we toss these values that came with the data that was stored natively. Don't want those because we've got it in this nice new clean format that Cosmos understands. Tidy up, clean some data right here, and then we patch it asynchronously with the flight ID, and then we mentioned custom telemetry. So that's our function that listens to every piece of data that comes in. Any questions on that?
Can we see that partition key there? Like in the Cosmos, that in the last call where you actually stored the data, you actually set the partition key there, right? So you mentioned that it's expensive to query for that geo data from the database. That's possibly why, right? Because we are using the partition key for the flights, and to get those spatial data, it's probably doing lots of cross-partition query. That would drive up the cost in DTU.
Yeah, that's exactly right. Yes. So the partition key of the table that has everything in it, I decided that flight made the most sense. So all the data of the same flight will then be placed on the same physical partition in CosmosDB. So if I want to get data related to the same flight, that's cheap. But if I want to get data across all different flights, like the location, like you just said, yep, it's going to have to read across partitions. Gets kind of expensive, so not optimal partition key choice for doing anything that doesn't, if I don't know the flight or I don't care what flight it is, I care about something else. Yep, various queries there will get quite expensive. And then I have a durable function that fires up. I've got just the pattern for durable functions. Durable function being one that has state. So unlike the function I just showed, which can run for a maximum of 10 minutes, and then it just times out actually. Default 5 would extend it up to 10, after which that's it. If it runs longer than 10, you chose the wrong solution, and so you need a durable function if it's going to run longer than that. And so that's what this particular one is, because doing all the processing on that other table to calculate all these distances does take more than 10 minutes on my CosmosDB. It is pretty expensive too, so I have this wake up once a day. Runs in the middle of the night when my Cosmos isn't too busy. Because you pay for DTU, so when it's because I don't have any flights going over at night, so my Cosmos is not so busy, so it has more DTUs available, because there's a minimum I have to set it, which is 1,000 in my case. This job it'll max them all out, but then it's not the DTUs are not being used to store incoming data at the same time, and so because I'm reading from that table, processing it, so runs in the middle of the night when the Cosmos is lightly used, costs me less money, and runs a query on the Cosmos, which is this one right here, flight ID, account of those flights, the maximum timestamp here, last seen. Here, this query, this is the geospatial work that I want CosmosDB to do. So this ST distance is, can you see that? ST distance is capability that uses the geospatial in Cosmos. Type point is the type is expecting, and then I pass in the coordinates that it's looking for, and does the math right there in Cosmos. Cosmos is gonna do the math for me as a result of this function calling this query on my CosmosDB once every night. And then the results, when they come back eventually, I process them one by one and move them off it. So get them all, update them all. This and this. So these are the bits that do all the work, and it processes it through. Okay, let's spend more time on that. In the interest of time, been here a while, so let's just quickly show the rest of the things that we have. Let's see. And my voice is getting hoarse from all this talking. So the crux of this whole thing is, I mentioned Stream Analytics does all of the work. So I'm going to group it by type. One application insights with our custom data. I won't show that in the interest of time. Connectors for Cosmos, so it's my Stream Analytics. I have a data factory that I didn't end up using. One function with multiple functions in it, right there. My flight processor function, multiple functions. The IoT hub, I'll show that. Actually, let's show that first. Let's show the IoT hub, because there were some questions around that, and like, why aren't you using it? We are using an IoT hub. Standard tier with one hub unit, which was all I needed for processing all this data. I have IoT Edge device management in this thing, where I can see and control my devices. I have just the one, which I creatively called Cloudy IoT Edge, which is healthy. It has 4 modules to it, and so connected and deployed, and I can. There's a whole UI up in Azure that I can use here to control and manage my device, send updates, things like that. Retrieve the device information. I can set the modules, enable it. These are the individual modules. There's data fetcher right there. Status running. various settings that I can update on this thing in order to do it. Send a method to it directly. Can troubleshoot the thing. And these are the logs off of my device right now. So you saw in my code earlier that I had a duplicate timestamp check in the code, which is basically pretty much the only data cleaning. There it is written to the logs in the last 15 minutes. So you can see it's busy, it's doing stuff, looks good, not dead, no errors, so hunky-dory. So all right, okay. And then let's see what else is interesting. No. The resource group, didn't mean to do that. Going to show my IT hub. I meant to show, we have a lot of settings and configurations in here. I was just going to show number of messages. So 13,000 messages ingressed to my hub, total messages out of the maximum that this is quota. So, you know, you can see it busy to there, 5 for 2006 so far. And messages from the device to cloud. So yeah, nice and busy, one device. Okay. And then my container registry where my code is stored, not really very exciting. One repo with my data fetcher container in it. There it is, built for ARM64. Not much there really. That's where my code is built to. Not very interesting. What else we got? Let's show my, I'll go to aircraft analytics. That's the heart of the whole thing. I was messing around with cognitive services, but I haven't used that just yet. We'll look at CosmosDB in just a second. We have the cold storage right here. Oops. Again, not a massive amount to see in this, except for how much data we've got. So we've got 11 gig of data in here so far in the blob storage, but actually that's junk. I don't know what that is. The tables is where we're actually writing the content right here. So 22 gig of data sample. I get 42 million entries, records counted in here. So fair amount of data. We're getting to the cost question in a bit. How much does this all cost? Yes.
When you were sending these messages across, via IoT Hub / Event Hub, did you have to account for or mitigate anything around the message size, or was it just good fortune, like these messages, the amount of flight data just fits nicely within the limits?
I didn't have to deal with that. This data does fit within those limits, but I would have to compress it. What happened was, I broke it up, right? I broke them in, as you can see, we've got one page of data with every flight per second. So the content of the page was too big. I started trying to send just that whole thing, just bang, and then figure it out later, just grab and toss it. It was too much. So I did break it up into individual records to make them all much smaller. So one line of each aircraft, pretty small amount of data, and which increased the message size quantity dramatically, but got under those limits. So I had 20 times as many messages, but they were obviously much smaller.
But you'd never hit the limit because you couldn't really predict how many flights would be around, or your device would pick up on around you any given time.
I had no idea.
Just wondered because it kind of just varied based on number of flights. So
yeah, I had no idea. So that is how I solved that problem. Rather than risk, too much in one message, just broke it up into lots of, because each flight is a pretty small amount of data. I know what that is, right? Each flight, pretty tiny. I know what the schema is. It's pretty tight, not a problem.
I was doing some cost analysis on the fly when you mentioned the logic apps and getting away from cost wise. And now that makes total sense. Because when I was looking at like even maximum number of seconds per day, I was like, well, it's bad, but it's not too bad. But if you're splitting it out into each individual flight, oh my goodness.
Yeah, that's what I found. Yeah.
All right.
Yeah.
All right. Thanks.
That was a fun learning experience, let me tell you. Okay, stream analytics. So let's look at the stream analytics job, because this is the thing that does all the work. So I have one input. I can have many. I can't change anything because, as you can see, it's busy running, busy, chewing away. One input, which is the hub. I can have multiple inputs on IoT stream analytics, but I just have the one. And I have 4 outputs, and then they're too small on my screen. Oops, not that small. Okay, fine. These are my outputs. So I send it out to table storage, CosmosDB, Service Bus Queue, and Power BI, as you saw in my diagram right there. And we can see how busy it is. So this is how I got so number of events coming in, events coming out, in terms of the thousands right there. So pretty busy. But the utilization, you see, it's not too maxed out, even though I actually have it do kind of a lot of work, actually. And I gradually added the amount of work that I had this thing do over time, which is, let's go right here. All right. So let's see this. Okay. And so I'm editing the query, and it's showing me the actual results that it's going to pull out, that it pulls out. So in editing this, I can see the raw data, the value number. So these values I put in on my IoT hub. This data aircraft is the raw content of each record for whatever was found, whatever I pulled when I split it up. So this is the raw JSON. There it is. Not too big. And then various other information that we sort of capture. And so just showing the the query here, this is where all the work did. So I have an object called all flights, which is basically, as it might sound, just everything that comes in that I build up, and I do various kinds of data. So I found, right, for example, the flight had spaces in it. Sometimes the data was kind of messy. It was kind of ugly, so I had all kinds of problems with that. So I figured out I can just do a right trim. So I just clean that right here, and that's my partition key. Set a row key as the now value. The current second, in fact, is the row key for this data. This ensures it's unique. And then the ID I built, so the ID for Cosmos has to be a unique value. So I concat the current time and the flight together, basically, to give me a new unique record for each entry in my Cosmos. That gives me the ID right there. And then, as you can see, I just build up all of the values. Some of the data was junk, so I do some casting where it didn't come in quite the right value or didn't appear right. Some of this I could perhaps have fixed on my IoT Edge as well, but lazy developers, I mean, what are you going to do? Developer was too lazy. He could just change it. Just fix it right here in Stream Analytics rather than change the code. So that's what I did. And then here's where, to Andrew's point earlier, we are doing the second time we're actually using the geospatial this capabilities this time of Stream Analytics to do some maths from a known value, basically pulling in the values currently as they are in the data. Obviously not cleaned like I put them in Cosmos later, but this is just as it comes in straight off of IoT Hub at this point, of course. Pulling from IoT Hub, and then I actually, you have to have a timestamp value. I actually pull the timestamp from the data rather than using the now value that the data gets in order to use the. I define the timestamp here. Didn't have to, otherwise it's going to pull the actual time the data comes in. I use the data of the record, and then let's see. And I also ignore here any data that's the latitude and longitude is empty. So where I don't have data in these two, I skip that. Just never mind. I built another one called Close Aircraft, which has slightly less data in it. And then Very Close Aircraft, where I actually calculate ones that are really close. And then I do another select right here in order to put it into the storage account, which I've called. Actually, yeah, this is the table storage aircraft right there from the All Flights one that I built. Then I select into Power BI just these values, not everything, just some of those, some of which I've calculated, right, including the distance and meters right there, calculated value of above. This gets sent to Power BI, and then I build into Nearby Aircraft, which is my event hub. No, sorry, service bus. My service bus is Nearby Aircraft, so here's where I drop these values in over a 3-minute time window. And then finally, all of this data into Cosmos. And that, friends, is 2.5 hours, probably enough. And I see folks are dropping. So I'll leave it there unless anyone is really keen. I mean, that's the majority of the solution, and the core of the work is right here. I can see some improvements that folks have suggested. I think we've seen it all. Any questions or feedback or anything that I didn't show that people want to see?
Cost.
Oh yeah. Okay. Fine.
Surely the right phrase is "show me the money."
Yeah. How much did this cost? Oh, can't. Actually, okay, darn it. You know, I can't show the cost of this one because this is a particular Azure subscription for which cost management doesn't work. And so I can look into, so it's not that great. I can look at, see how much this one costs, current billing for this one. These are all, this is all I can see, right? In this type of Azure subscription. I don't have Azure Cost Management available to me because this is a particular type of Azure subscription called a sponsored subscription, just a particular type that we have that has limits on the cost management because it's basically prepaid. There is an amount prepaid on the subscription, and when it's gone, that's it. I mean, it's done, or it expires after a period of time. So cost management isn't a thing, and all I can see so far is the most expensive services that I've got. So I've spent a lot on Azure Monitor, it seems. Wow.
I request to be sponsored.
Yeah. Do you see this one? Look at this. Look at this logic. Azure Monitor's totally got away from me. Look at this. Look how expensive Azure Monitor is.
Hey, Adam, there's a Corvette I'd like you to buy me, okay?
If you go back a page there, you might be able to tweak the date and just see like a high level for your subscription, what it is, just in usage details.
Oh yeah,
and just tweak those to and from dates just to a month, I guess. I know you probably have other things running in that subscription, so
but you're right. This is most of it. This demo, yeah, good point. So let's do from yesterday to today. That's this one.
Oh,
okay,
that's nice. That's a nice view.
Yeah. Thank you, Sergio. This is better. This excludes all my mistakes. I was actually just showing you there briefly the cost of the logic app. I remember it's that. Yeah, do you see it in there? There it was.
Yeah, it did.
Oopsies. Yeah. Okay, there we go. 1 day's worth of spend. Not a lot. $70. Let's see what we're spending money on. Seems kind of low. I'm gonna make it a bit bigger. A little more than that. Yeah, so funsies. Because these are good, important questions. These matter. This is list pricing, nothing special, I think. So,
and it looks like lots of those stuff are not related either, like virtual machines, right? So the actual project cost is probably tiny from.
Actually, it is pretty tiny. So I'm going to pick from February 21st to the 24th, a couple of days. I think I got that right. Yeah. And let's see, what did I spend Azure Monitor has got away from me. Look at this. Oh, no. What am I doing? You know what that is? That is Kubernetes. That is Container Insights has gone.
It didn't limit the work analytics space digestion size or limit, right? So it just unlimited basically.
Yeah, look at that. Whoops. This is how we learn, right? So need to look at that. But anyway, I'm not using that for this project. That's something else. But for this project, application gateway, what are we using? Like a Bastion. Stream analytics. There we go. That's that. I only have one. The stream analytics. That is this. That is there's $7 in stream analytics. Yeah. So and here's my Cosmos. Only the one. It's honestly not for the RUs. Let's keep going. IoT Hub. There we go. Not a lot. Here's my data stored in my Cosmos. Not much. And then functions, execution time. We had a question around that, 13 cents. Not a lot, team.
Wow.
And I've got some storage in various storage accounts, some execution functions. I mean, this is all we're getting. I sorted it by cost, so this is all very cheap. Most expensive part of this would be Stream Analytics. Yeah, there you go. And I've got a premium container registry that is costing me a massive. It's not super cheap, as you can see. And there's Cosmos. Yeah. So honestly, yeah, this is not a very expensive solution. It is in summary. Not a lot. All right. Anything else? Anyone I didn't show? Anyone wants to see?
Did you record?
Yep.
Got a couple colleagues who couldn't come, so thank you. I'm going to drop off. Thanks and goodbye.
Oh, okay. Yeah. Thanks, Henry.
I've got a super quick question. Again, very minor and related to what I was asking before. So the bit about the location of the device, using it as an example of a piece of configuration. Of course, the issue is you don't want it embedded in multiple places. You get your typical maintenance nightmare there. Now, of course, if you have multiple devices or they're moving, then it ceases to be configuration. It becomes part of your event stream. But just for configuration in general, you still do have some configuration data there, things like the radius for your very close and close. Mm-hmm. And this is really a broader question that where would you choose to store configuration data for a broadly based Azure services kind of app using many different services, which to my mind would be based probably on, because there's never going to be much data, it's going to be based more on it being stored in a fashion that is easy to get to from almost anything.
Mm-hmm. Mm-hmm. Got two real options. Much of it, so IoT Edge has the ability to store various local properties that you can set. So for each individual device, I would has environment variables, things that you can set per device for variables that are changeable that are specific to a device. That'd be one, the local. In Azure, there is a configuration service, actually a service specifically designed and only for storing configuration settings.
Well, there you go. That's the obvious answer, and clearly something that I hadn't stumbled across. So thanks
you
for
are
that.
not the only one. It is a very little known service. Take a look. It is for centralized configuration as a service. App configuration. Thank you, Sergio. He put the link in the chat.
Well, I've got to drop off as well, and thanks for the presentation.
We've been going for 3 hours, so this is more than enough. And I want to thank everyone for sticking with me who's still there. I hope this was interesting and fun. I had a really good time. I hope somebody else found it interesting. Thank you all for joining us. We have a presentation next month on auto scaling of Azure functions using CADA that we can. Done by a previous presenter and a colleague that I'll post shortly. So thank you all. I will see you all next month.
Did you have dinner yet?
I did have dinner.
Good.
Yes. I'm gonna
Thank you, Adam. It was such a great session. One of the